Joining us today is Dr. Jacob Klein with the Weizmann Institute of Science, also the 2015 MRS Turnbull Lectureship Award winner. Thanks for joining us today.
Sure, it's a pleasure.
Now, the MRS Turnbull Lectureship Award is somewhat unique in that it honors both the research as well as the communication of that research. Your citation, in fact, cites your inspirational lecturing and academic leadership. So let's talk about the importance of communicating your discoveries via teaching and publishing.
Yeah, I think that that's really very important. I'd say research, of course, is on a different plane, but communicating the results, especially to people who are not experts, I think that's particularly important. And it takes work. I mean, it's much easier to hide behind all sorts of technicalities and stuff like that. And I basically think that if I can't explain what I'm doing to an intelligent high school, and I've lectured a lot in high schools, then I don't really understand it. You know, Feynman used to say that if you can't understand something to a freshman level class, then you don't really understand it. However complicated you think you understand it, and so on. If you can't explain it to someone, an intelligent person, but without the prior knowledge, then you don't understand it. So I find that explaining to people in schools and fresh undergraduates and graduates means that I really need to understand what I'm talking about, and that's very useful.
So let's talk about your award talk. It's titled Soft Matter Across the Millennium. First of all, what is soft matter?
Okay, that's a good question.
Thank you.
Soft matter, it's a relatively new term. I'd say it's been around for maybe 2-3 decades at most. It bundles together a whole lot of things that used to be called differently. I mean, it's polymers, it's colloids, it's surfactants, it's biomaterials, which are all soft. And really what brings them all together is the fact that what is important are the length scales and the energy scales. And the length scales are of the order of a few nanometers, and the energy scales are of the order of thermal energies, kT. And if you divide kT by a volume, which is like a few nanometers all cubed, you get a modulus. And that modulus is a soft modulus. And an example, if you just move your nose back and forth a bit, the cartilage in your nose, that's typical soft matter.
And these are all things you're going to be talking about.
A little bit of that. This we did decades ago. And then, I mean, typically there is things like, if you're talking about biological materials and people are applying their ideas more and more, tissue engineering, the properties of scaffolds and so forth, how to get the body to repair itself, that has a lot to do with the properties of soft matter as well. Colloidal dispersions, which occur in billions of practical effects. So if you just look around, almost anything, you know, paints, inks, everywhere, the effects are everywhere. Yeah.
Dr. Jacob Klein, thank you so much for your time. Good to meet you.
Sure, thank you.